Hi everyone, I'm Jenna Charlton, and this is Agile Testing Basics for Non-Testers. So I'd like to just share a little bit about me, kind of so you know who I am. So I've been testing for about 10 years now, and I've actually made a transition from testing every day to being a training consultant for a company called Coveros. What that means is that I primarily teach software testing and Agile skills. I am a deacon at my church. I love pro wrestling. I love punk rock. And I am really into web accessibility. Also, feel free to connect with me on Twitter. That little cupcake is a sticker I like to give out. So I'm She Wrestles Test on Twitter. So let's start with kind of dispelling some preconceived notions about testing. There are a couple things that testing is not. Testing is not checking. Now, yes, there is some amount of verification, maybe checking off some boxes on a checklist. But testing is so much deeper than that. And testing is also not a guarantee of bug-free software. In fact, there is no guarantee of bug-free software. It doesn't exist. We talk about in testing the 7 principles of testing. And one of them is that I can show you defects. I can find them for you, but there's nothing that I can do that prove that they're not there. So I can't prove the absence of defects, only their presence. And because of that, testing is definitely not a guarantee of bug-free software. Nothing is. And finally, testing is not bug hunting. Do we bug hunt? Absolutely. But what we do is so much deeper than that, especially moving into the Agile world. Testing is much more than bug hunting. So what I want you to take away from today is all of the things that you as a developer, or maybe a tester as well, are doing in testing and the ways that you can enhance what you're doing. Since all of those things are things that testing is not, here is what I believe testing is. Since testing isn't checking, testing is about exploration. And when I say exploration, yes, there is a test technique called exploratory testing. It's an experience-based technique. But no matter what, as long as you are thinking through your application and really thinking about the nature of what's been built, you're doing exploration. And exploration is a much better descriptor of what we do when we test. And since testing is not a guarantee of bug-free software, instead, it's this idea of good enough quality. And we're going to expand on that a little bit. But I want you to keep that idea of good enough quality in your mind, because that's what we should be shooting for. That's what we should be trying to reach. Testing also is about advocacy. We are the advocates of our users, we're the advocates of our customers, and testing is about really thinking about what they need. Because when we build software, we're solving people problems with technical solutions. So if we're not thinking about the people, and we're not advocating for usability and for accessibility, and advocating for our own needs as well, so advocating for really good clean coding standards and for really good development-based behaviors, we're not taking care of our own needs either. So it's all about advocacy and making sure that we're thinking about all of the parties, all of the stakeholders, including ourselves, and what we need. And the other thing I want you to keep in mind is that since we cannot create perfect software and we want to get to good enough quality, testing is about risk assessment and risk mitigation and managing risk. Knowing what's risky helps us to make determinations on what is good enough. So keep all of these ideas in mind as we continue to talk today. So people ask me all the time, well, okay, fine. You're saying there's testing is these things and testing isn't these things, but come on, how many ways to test can there really be? I get people really say this to me a lot. And I'm gonna be honest, I don't know how many different test types and techniques there are. There's so many of them that I couldn't even begin to count them all. But this is kind of an inexhaustive list. And myself and some tester friends, we kind of put this together. Now, some of these you've probably heard of, like you've heard of performance testing, you've heard of usability testing, but you may not have heard of things like multivariate testing or things like fuzz testing, although that's becoming more common. So there's lots and lots and lots of different ways and techniques that we use when we test. Some of the ways that we get to really determining what the right kind of testing to do is and the right way to approach our testing is to think about the vocabulary we use when we test. And this is some of the stuff that you may have heard thrown out in conversations with your testers and gone, I have no idea what these folks are talking about right now. So some of these you may have heard and some of them you may not have. Unit testing, I hope if you're a developer, you have heard of unit testing, you know what it is. Unit testing, of course, is closely coupled to the code. We're focusing on the technical correctness of the code that's been written. We're looking to make sure it's programmatically correct. And unit testing is super important, but it's also not really the same as the other kinds of testing we do. Because while unit testing can help us know that we've built quality software from the perspective of the code, it is not going to tell us whether our application really meets the needs of our users or is functionally correct based on the requirements or the user stories. We get to looking at functional correctness when we look at doing functional testing. And functional testing is all about the functional testing of the requirement of the story. This is looking at what the story should do or what the app should do. So this is all of the what behaviors. And then we look at non-functional testing. And you're probably saying, okay, well, functional testing, fine. We're testing how it works. But non-functional testing, we're talking about how well does the app do what we ask it to do. So functional testing is like, what does it do? Does it do it correctly? Non-functional testing, we're looking at how well does it meet the standards we've put forth for the quality characteristics in our application. And these are things like the ilities, so security, accessibility, usability, some things that we consider part of the ilities but aren't named that way, like performance and load and stress. These are all of those quality characteristics that aren't necessarily a pass or fail. They are on a spectrum of how well does it fall, how well does it behave within that spectrum. And then we've got this idea of smoke testing. Smoke testing, people get really confused on, but really all it is testing the most critical functions through your application. This is the kind of test that you do after a build. This is the kind of test that you do after you go to production. Most basic, highest criticality functions in your application. And I want to talk about these last two, sanity and regression. Sanity, people get so confused on. People think sanity and smoke testing are interchangeable, but they're not. Sanity testing, or confirmation testing, the other thing that people call it sometimes, is all about just the changes. So if you have fixed a defect and you go in and you test that defect, that's sanity or confirmation testing. Then when you go to make sure that you didn't break anything else, that's regression testing. So we do confirmation or sanity testing to make sure that our changes worked. And then we go and do regression testing to make sure that we didn't break anything in our application associated with that fix or that change that we made. All right, so I've bored you with vocabulary, but I think vocabulary is really important. And I think it's really important because it helps you to have a really good conversation with your testers. It helps you have shared language. But let's talk about how some of these concepts that I've already shared and some of these ideas that I've introduced in that vocabulary works together to make quality happen. I believe that quality is about the team. I believe the whole team owns quality. I believe everybody has a hand in it. And I believe that the software testing pyramid is a really good visual example of how that happens. So at the bottom of our pyramid, we've got our unit tests. That's actually the biggest suite of tests in your application. And that's because they're very small tests. It takes a lot of them to give you good coverage, but also because unit tests protect you. You're not going to send broken builds out to your testers to do testing. You're not going to send broken software out to your production environment if you've got good unit tests that are running on your builds. And then we've got all of these automated tests. We've got our component tests. These can be component tests and component integration tests. We've got integration that could be component integration or system integration. We've got API tests that test our API level. layer, we've got our GUI tests that test our front end. And then up here at the top, I kind of put it in its own little cloud, we've got our manual tests. I believe that if you combine test-driven development, so doing really good TDD, very intentional TDD with high quality unit tests, along with a comprehensive suite of automated tests driven by either behavior-driven development or acceptance test-driven development, combined with really high quality exploratory manual testing, this is how you get to really high whole team quality. This is how you get quality software. Now, is it going to be perfect? No, because perfection doesn't exist. But is it going to get you closer to really good quality? Absolutely. So one of the things that I want you to keep in mind when we think about testing, and I mentioned this already, this idea of testing being about risk, is that to get to a nice high level of quality, we have to identify what we should focus on. There's no way we can test everything. Our apps are too big for that. So instead, we think about risk. And when we do that, we think about a couple of different factors. We think about the complexity. And when I talk about complexity, I don't just mean cyclomatic complexity, although that's important to understand your cyclomatic complexity, to have standards around it. But this is also how interconnected is this feature or functionality within a system of systems? How interconnected is it with the rest of the application? How hard is it to maintain? How much do we really know about it? That kind of tells us our complexity. And then we think about our likelihood. And likelihood is also your history. How often does this break? What is our running history with this feature or functionality? How often do we have problems with it? So that tells us what the probability is that something's going to go wrong. And then the impact. What's the impact of a potential failure with this feature or this piece of functionality if something goes wrong? Are your users completely locked out? Are they not able to use the app? Does it shut your company down? Are there financial penalties? Are there legal liabilities? What's the brand impact? So I take these three factors of complexity, likelihood, and impact. I usually use math to do this, and I calculate out a total risk. Now I'll tell you, the math that I use is that I assign each of these a score between 1 and 5. So complexity, likelihood, impact between 1 and 5. And then I take either the complexity or the likelihood, whichever is higher, I multiply it times the impact. And that gives me a score somewhere between 1 and 25. 25 being the highest risk, 1 being the lowest risk. And that helps identify where we should focus our testing. Now, there's a lot more to risk than what I'm talking about right here. People do whole talks, workshops, 3-day classes on risk. So this is just a really brief intro, but it's something that I believe is really important as you think about your testing and as you think about building applications and how they need to be managed and how you mitigate the potential risks associated. Now, since testing is about risk, and since we can't get to perfection, we have to shoot for this idea of good enough quality. Sheryl Sandberg, feel how you will about her, said that done is better than perfect. And this, I think, is 100% one of the most correct things somebody can say about building software. Our goal is to finish things. We're not going to get to perfection. So we want to get to a definition of done. We want to get to a finish line that meets our minimum viable product and is an acceptable level of quality. When I think about this idea of done being better than perfect and getting to that finish line, I think about training for a marathon, because you don't go from, hi, me, I don't run, and if I'm running, you should run too. Something's behind me if I'm running. But you don't go from me to running a marathon tomorrow. Instead, I'm going to set goalposts for myself. I'm going to set finish lines that can be negotiated. So my first finish line might be training for a 5K. And then my next finish line is going to be training for a 10K, and then a half marathon, and then finally doing that full marathon. And that's where I get to that, that goal, that definition of done that we set out. That was our plan for our final definition of done. But you know what? I don't have to be done there. There's potentially more risks we can mitigate. So I may then start training for an ultra marathon, or training for a Spartan race. So just because we've mitigated the risk that we've originally identified and we've met our original definition of done, doesn't mean we have to stay there. That finish line can continue to move as we need it to move forward. All right, so the last thing I want to share with you, I've given you a lot very quickly, but the last thing I want to share is a couple of test techniques. These are black box techniques that are really, really valuable in thinking about unit testing and in thinking about automated and manual testing. So the first thing I want you to think about is scripted testing. Now, scripted testing is very driven by the test objective. We're just using step-by-step instructions. So if your goal is test the login page, you're going to have step-by-step instructions to test that page. You're going to have an objective that is prove login page works. This is a lot like using a GPS system. It gives you turn-by-turn instructions to get you to the goal. One of the big problems with scripted testing is one of the 7 testing principles of the pesticide paradox. And that is that we can eradicate all of the defects associated with those scripts and still have defects there that are associated with other potential sets of conditions or with other data sets. So it's really important, if you do go this route of scripted testing, that you are varying up your data. And then we have exploratory testing. This is my heart. Exploratory testing is what I love. This is very risk focused, and it's focused on exploration. Instead of step-by-step instructions, this is like using a treasure map to explore your application. And you're building that treasure map dynamically as you do your testing. So what we do is we set a time box, and then we break that into sessions. And we use that as an opportunity to try different data sets, different sets of conditions, look at multiple ways to approach the testing that we're doing. This is where you find all of the unknown unknowns in your app. Automation is great. It's going to help you find known unknowns, but exploratory testing is where you find all of the big surprises that you had no idea could happen. A couple more techniques for you on the black box side. I love these 3 techniques of equivalence partitioning, boundary value analysis, and decision tables. And you may have heard of these before. Equivalence partitioning is where we identify both the valid and invalids for a potential test case or a test objective that we're looking to prove out. So if I was to have maybe a mortgage application that I'm testing, and the only thing that's valid in that mortgage application are people. I could have 1 person or 2 people as a couple. Those are the only acceptable inputs. And then everything else, a corporation, an LLC, all of those are invalid. And you use this technique by identifying your valids and your invalids and using those to identify test cases. Boundary value analysis, on the other hand, is meant for math. So we would have a spectrum. Let's say that you have a commission system, 0 to $10,000, you get X amount, 10,001 to 20,000, you get Y amount. And you would identify those boundaries and do testing around those boundaries. The huge benefit here for developers is that you can catch any logic errors you have. So your math is wrong, you're off by 1 because you used greater than instead of greater than or equal to. Super valuable technique. You can find all sorts of resources to get started with these techniques online because I don't have quite enough time to walk you through them. And then the last one is decision tables. Super useful for identifying business rules and for identifying all of the test cases you would need to test a rule. And then there's 2 white box techniques I want to share with you. And this is looking at statement and decision testing. Now you've probably seen these before. Statement testing, we're just testing the one path in a statement, one half of the decision. In decision testing, we're covering both parts of the decision. Now, there's a whole lot more to these white box techniques than just statement and decision, but these get you started. And then once you figure those out, you can run down the path of doing multi-condition testing and multi-condition decision coverage and all sorts of other techniques that can be used. What's important to remember here, and this is especially important for your unit testing, is that statement coverage, statement testing only gets you at most 50%, because a statement, as long as it has 2 paths, you're only covering one of them. So when you do decision coverage and you build decision tests in, you're covering all of the paths, which gets you to 100% coverage on those unit tests you're writing. And the last thing I want to touch on is automation. So I will tell you, while I am a manual tester at heart, I do love automation. I do believe that it really provides value. I think that we need to be intentional about what we automate. So we need to automate our repetitive tasks. We need to automate the things that we need to do over and over and over again. Because I will tell you, my least favorite thing in testing is to test the same thing over and over and over again. You want to automate your pain points. What is really hard to test? Take that struggle, take that pain off of your testers. Automate your pain points so that they don't have to do really nuanced, ticky-tacky testing all the time. That if you take that away from them, they are able to focus on much more valuable exploratory testing that will really deepen everybody's understanding of the application. And then I want you to think about what you're missing when you do automation. I mentioned this idea of known unknown and unknown unknowns. Automation tells you all of your unknown or all of your known unknowns. Exploratory manual testing tells you your unknown unknowns. That's really important. If you go automation only, there's a lot you're going to miss. So you always want to think about what you could be missing. And that is a very high level, very quick Agile testing basics. Feel free to grab me on Twitter. I'm going to go through the questions that you all have and see if I can answer them for you quickly. So question 1, can you provide guidance for getting started for newbies? Absolutely. I love newbie testers. Couple of great resources. Ministry of Testing, fantastic resources. There's some amazing stuff both for free and as paid resources. They're great. There is conference talks up there. There are 30 days of testing challenges. There are get start guides and like whole classes. Also, if you're interested in getting started in automated testing, Test Automation U is fantastic. I'm sure you all know Angie Jones. Angie was one of the primary drivers on starting that. Fantastic resources up there. Also, if you want to take a class, reach out to me. I will be happy to get you in software testing foundations and get you started on testing. Question 2, in an advocacy perspective, how should developers interact with other stakeholders to ensure their tests validate the right things? In other words, what's the best way to discover testing requirements? Well, that's a good question, and that's a big question. Okay. Oh, I love it. All right. So from an advocacy perspective, developers should be thinking about primarily all of the different conditions that are associated with the story that you've been presented with. Think about using some review techniques like scenario-based reviews or like perspective-based reviews, and think about all of those scenarios. Then after you've identified all of those scenarios, you are going to start deriving all of the different conditions associated with it. I know some people who do this using mind maps. I also know people who do this using like spreadsheets. I personally am a spreadsheet tester. I like to make big decision tables and use that. And then after I've identified my conditions, I'll often go sit down with the developers and the business analysts and say, hey, here's everything I've identified. Let's talk about these. Are we missing anything? Do we think that there's some conditions here, some sets of conditions that aren't possible? Did we accidentally allow the user to do something based on these conditions we don't want them to be able to do? Some other advocacy things you can do if you happen to see that the way a story is structured is going to make something difficult for the user. That's really a good opportunity for advocacy. And as far as validating that you're testing the right things, pair up. Pair with a tester, pair with another developer, spend some time doing shared ideation. There is a lot more to this, but it would take me like an hour to walk through how to go from like test basis, which is what the requirement is, to test conditions, to actual test cases. So hit me up on Twitter and I can give you some real resources that'll get you through that whole process, because I don't have enough time, unfortunately. Question 3, I think testers would interact with stakeholders rather than developers, if I'm not wrong. What do you think? I love working with developers as a tester. I do work with stakeholders, but I like to spend lots and lots of time with my developers doing pair testing. I like to sit in on code reviews because while I am not a great coder, I certainly recognize code patterns. I can pick out smelly code. I like to be part of pair programming sessions and doing mob programming and pairing that way. I learn more about the application. They learn more about how I think as a tester. So yes, testers do interact with stakeholders, but testers and developers should absolutely pair and spend a lot of time together, especially in Agile. Question 4, is it possible to automate functional tests? Absolutely. If you do behavior-driven development or automated or acceptance test-driven development, those are all tests that you can automate. All of your acceptance criteria should be able to be automated. If you cannot automate your acceptance criteria, it doesn't pass the testability test, meaning that that user story or that requirement should go back to your stakeholders to be redeveloped because it is not testable enough. There's no reason you can't automate about 90% of your requirements. All right, I'm out of time. See me on Twitter if you have more questions. Thank you so much for having me.